So for number 49, we want to find out if this sequence over here converges. And now a sequence an converges if it tends to a defined limit as n approaches infinity. So what we're going to do here is we're going to take the limit as n approaches infinity of ln of 2n squared plus 1 minus ln of n squared plus 1 and see if this spits out a defined number. Now if we just evaluate this limit right now, it's going to give us the limit of ln of infinity minus ln of infinity. We don't know what to do with infinity minus infinity, so we're going to algebraically manipulate this. And now we're going to use the log rules that says that log a divided by b is equal to log a minus log b. So if we compare this, if we go ln of 2n squared plus 1 minus ln of n squared plus 1, if we compare this, we can see that the a is the first term, so that's going to be on the top, 2n squared plus 1, and b is minus ln n squared plus 1, right? So that's going to be on the bottom. That's going to be n squared plus 1. So we have seen how to transform this into a quotient, which we like. So we're going to say this is the limit as n approaches infinity of 2n squared plus 1 divided by n squared plus 1. Okay, now let's just take the limit as n approaches infinity of the inside part and see where it goes to. So that's going to be of 2n squared plus 1 divided by n squared plus 1. So if we just evaluate this limit, this is going to give us infinity over infinity, right? 2 infinities divided by infinity. So we don't like that. So what we're going to do here is divide by n squared. So we're going to divide the top and the bottom by n squared. Just so that we can get rid of those higher powers and turn this into a quotient, which we like when dealing with infinity. So this is the limit as n approaches infinity of, let's see, 2n squared divided by n squared, that's just going to be 2 plus 1 over n squared, divided by n squared divided by n squared is 1 plus 1 over n squared. Okay, and so if we take this limit, on the top this is going to be 2, right? Limit of 2 is just 2 plus 1 divided by n squared, so 1 divided by infinity, that goes to 0, over 1 plus 1 divided by infinity, that also goes to 0, so this is equal to 2. And so because we've shown here that the inside part goes to 2, this is equal to ln of 2. And so because ln of 2 is a defined number, we can see that we say an, it tends to ln of 2 as n tends to infinity, so an converges. So we've shown that the limit here is ln of 2, and so it does converge.